I'm going to start by telling you what a sequence is. A sequence is an ordered list of numbers. So A1, A2, A3, AN. So again, it's just, think of it as just being a list of numbers that have an order to them, okay? A first term, a second term. So we call A1 the first term. It's the first term. A2 is the second term, and so forth. So in general, AN, what term is that going to be?
The nth term.
Nth term, yep. Nth term. Okay. Now you're going to see sequences written in a couple different ways, so I wanted to show you the notation for these sequences. So usually a sequence is just written most often with curly brackets and so forth. But there are a couple other ways. So sometimes if your sequence has a pattern to it, you might see it like this, or you could also see it like AN and then N equals 1 to infinity. They tell you the starting and ending. This is an infinite sequence that starts at A1, okay? All right, so when we come across a new definition, we want to see some examples, right? I need to understand what these things look like, which is sometimes hard to do from the definition. So let's just start with some examples of sequences. So the first one is going to be, I'm going to use this last notation, n over n plus 1, n equals 1 to infinity. So what this is telling me is that the nth term of my sequence is given by n over n plus 1. So let's write out some of these terms here. What's the first term? What's it? 1/2, right? You plug in n equals 1 and you're going to get 1/2. What do I get if I plug in n equals 2? 2/3. What next? 3/4. 4/5, right? And you keep going, and in general, the nth term is n over n plus 1. Okay, so that's one example of a sequence. Let me do the second one. Let's say not right now, we're just looking at examples of sequences. We'll talk about what we can do with them a little bit later, okay? So, let's say I take the square root of n minus 3, n equals 3 to infinity, okay? So notice now my sequence doesn't have to start at 1. That's the thing I'm trying to emphasize here. My sequences start at the number 3 in this example. So what's my first term going to be? Plug in 3, what do I get? Square root of 0, so what's that? 0, right? What's my next term in my sequence? Square root of 1, which is 1. And then after that, square root of 2, square root of 3, and you keep going. right? In general, the nth term is the square root of n minus 3. Okay. So I want to do one more example of these. So I'm looking at -1 to the n plus 1 over 3 to the n. So the terms in my sequence are given by this formula. And we'll start off by plugging in n equals 1. What am I going to get if I plug in n equals 1?
-2 over 3.
Negative. So if you plug in 1 in the top, you'll get a 2. 3 to the first. It'll be 3 in the denominator, right? Let's do the next one. So it'll be, I'm plugging in, so this one was, I plugged in n equals 1. Now let's plug in n equals 2. So I have -1 squared, +1, plug in 2. So 3 in the top, over 3 squared, 9, okay? All right, let's plug in maybe 2 more. N equals 3 and n equals 4. What do I get if I plug in n equals 3? -1 cubed. Negative, 3 plus 1, 4, over 3 cubed, 27, okay. Plug in n equals 4, -1 to the 4th, it's +1, 5, over 3 to the 4th, which is 9 times 9 or 81. Okay? So this kind of sequence I wanted to show you. Do you see what's happening to the sign? It's the first term's negative, second term is positive, negative, positive. So it's alternating, it's switching back and forth. And so this is usually called an alternating sequence if it's flip-flopping signs back and forth. Okay?